Oh my gosh, you said 3 and that's literally just growth or decay, and you said 5 and that's crossed out. Who really has a question about their homework? 10, 9, and 10.
Just off on the other side. Number 7. Yeah.
Are you being for real? Let's do number 9 first. Then we'll do 10. All right. First step is to find, actually first.
No, please, no. Nobody say anything except.
Is it growth or decay? Why?
It's because it's bigger than 1. The B is bigger than 1.
It's growth. Is it above or below the asymptote?
No, it's above.
It's greater than 0.
Oh, above. It's positive. It's above.
Above. A is a positive number.
All right. Where is the asymptote?
+1. Oh, wait, no. You broke that.
0. 0. The number on the end. Yes, Edward. K. Oh. Give me a point on my graph. No. H. A plus K.
It's 1/8. Negative 1/8.
So -1 and then up just a smidge. Okay. Yeah. Something like that. All right, pick another X. What X should I use? 0. Why 0? I'm adding 1 to that. What would my Y be there? You put it in where the X is, and I get 1/8 times 4, which is 1/2. So 0, 1/2, 0, 1/2. 1/2 is higher than 1/8. So when I connect these, it's going up to the right and it's hugging the asymptote to the left. Okay, it is. That's right. Domain. How could it do that, Sawyer?
She don't even know.
It keeps getting. What's half of 1?
We're doing this, but I'm going to go 3, 2.5, 2.25, 2.1.
I'm not subtracting a half. Yeah. Multiplying by a half each time.
So every time you zoom in, you can keep on going further, and that line that's supposed to stay stationary goes down.
No, not the stationary one doesn't go down. You know what?
I don't understand how I could go on forever and not touch the
Exactly.
One line straight, one line is curved and going down. It goes down the entire time. There's no physical possible way.
The asymptote is in another dimension.
It's done.
Look. My asymptote's at 0 because it's 2 to the X, right? You think it touches?
Zoom in. Go left.
Left?
Zoom in. What? Go left.
Keep going.
You told me that's not getting low. That's touching.
Zoom in.
It's below it. Wait, what's the point?
In fact,
What are the points for that? Just go to the farthest number possible.
I'm at 8,000.
It looks like it's touching there, Miss McGee.
It's not.
Yeah, it is. Where's the black line? You can't zoom in anymore. I was right. I was right.
Wait a minute, what's
Am I right?
Wait a minute, what is 0?
Look, it's not. It doesn't touch. It's an asymptote.
0.
This is frustrating. Okay. What's the range? No, 0 to infinity. It's because it can't go out but so many decimal places. So 0.000000001 is going to have to round to 0, but it's not actually 0. Okay. It's kind of like the decay, like radioactive decay and stuff that you learn about. It never completely goes away. It just cuts in half.
Yeah, I know what you're talking about.
Radioactive.
Yes.
I saw this on a podcast. Pretty sure.
You heard it on a podcast? What is the end behavior? How about the other end? That's right.
Notice the word up.
Y-intercept, what is it? 1/2, you already found that. No need to find it again. Asymptote is at y equals 0, and we're done. Yes. Or 0. Y equals 1/2. Or you can put 0, 1/2. Either one of those is fine. You okay? What Sawyer mean to you? What? Is that why you're sad? You miss Edwards? We all miss Max.
I do.
My mother heard Max in the video yesterday.
All right, number 10. F of x equals 4 times 2/3 to the x plus 1. Growth or decay? That's decay. How do you know? That's right. Above or below the asymptote? Above. Where is said asymptote? At 1. Y equals 1. Because it's decay. What value will the graph never be? Oh. 1. It'll never be 1. It'll never be the asymptote. Give me a point on the graph. 0, 5. How'd you get that? H, A plus K. 0, 5. 1, 2, 3, 4, 5. Give me another. What should I plug in? Yes.
So the adjective would be negative. Like 4 -1 over 3.
Yes. Okay, 1. 4 times 2/3 plus 1, that would be 8/3 plus 1, which would be 8, 9, 10, 11/3 plus 1, which would be 3 goes into 9, 3 times 3.67, 3 and 2/3. Because this is 3 over 3. I didn't want to take out a calculator or anything.
You have to make the bottom.
They have to have common denominators. Combine the top, leave the bottom line. So 3 and 2/3, I'm over to 1. I'm up to 1, 2, 3 and 2/3. You don't have to be exact. I mean, well, go past 3 some, but okay. What's the domain? Okay. Okay. Domain. Range. No, it's 1 infinity. That's right. Lowest, it's always bottoms up. So the lowest it goes is 1 up. Yes. So as x approaches infinity, what does f of x approach? 1, the limit notation, 1 over infinity is 0. Well, we just talked about if you keep cutting a number in half, 1/2, 1/8, right, it gets closer and closer to 0. If you divide 1 by a really, really, really big number, it goes to 0. If you could put infinity here, it would be 0. That's neither here nor there. We talk about that in calculus. What is what 1? Because on the right side, it's hugging this asymptote, which is 1. Flip-flops there. What else? Do another one? You need 11? All right, 11, and then we'll move on. Yeah. This is easy.
Like, do I have to tell? I know how to put it on the graph. I know how to do it. But the decay and above and below. So negative below.
Thank you. Okay, 1, 2, 3, 4, 5. And it's below the asymptote. What's the point on my graph? H.
0, negative.
4 2/3. Why? Oh dear. Plug in 1 for your x, and I will get negative 1/3 times 6 to the first plus 5. 6 divided by 3 is 2, and it's negative. Plus 5 is 3, so I have 1, 3. This is in fact growth, but it is a growth that has been reflected over. So that's what it looks like. What's my domain? As always, what's the range? Nah. What's the lowest the graph goes? Negative infinity up to the highest it goes, Jonathan, is what? Uh-oh.
The highest it goes is, yeah, the same thing.
5. What's what? 0, 4 2/3. Yes. 4.6666666. No. Y-intercept. We already found it, right? It's where x is 0. Same thing. 4 2/3 if you go around the world. 4 times 3 is 12 plus 2. Same thing. What am I missing? That's everything. Oh, asymptote. Yeah. What if it was a vertical asymptote? All right. Y'all ready?
No, we didn't do,
Oh.
I don't know.
In behavior, as x goes to infinity, f of x does what? Negative infinity. On the right side, it goes down. Did you miss that, Riley Grace? Yeah. You missed it too? So this means right side. The right side's going down. The left side is the one that's going towards. Whoops. Yeah. Y'all ready to solve an exponential equation? Yes. No.
You literally say that every single time we do something.
Today we'll stick with base manipulation, I think. Manipulate numbers. Really, you know how to do that.
got marker on it. It's like black.
It's all over my hands too.
Right here.
Down a little bit.
It's not coming off.
Yes.
It's just not the slide. Don't worry. It barely fits.
I just saw when I walked it. It was not there.
I saw it after she moved her hand off her face.
Golly, how did that get there?
Did I open the marker and just go boop?
I saw it there after you moved your hand.
That's embarrassing. I'm just kidding. What if you would have walked around with that one?
Oh my God.
Yeah, it'd be more embarrassing if we didn't.
Oh, well, y'all, I've done more embarrassing things. And I fell one time in class.
Oh, here's the key.
Like, what'd you do on the beach when people were yelling at kids?
She was walking in front of
Oh. That was probably embarrassing for everybody else. I probably embarrassed
What
them.
happened?
I showed out a little bit.
Oh yeah, I remember that story.
I also showed out another time at Rec Room.
Where?
Rec Room shoots.
In, like, here?
Columbia. 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 I'll have to, that's a story for another time. I'll have to share it with y'all. What? What'd you say? Aww. Did you ask her if she was okay? Aww. I did that when I was pregnant with Parker at school.
My mom, she's a teacher.
I know, I remember I worked with her.
She threw up every day after.
When she was pregnant? I remember when she worked here. We worked here together. Okay. Because she actually,
Why was she thinking that
I think she even brought dinner whenever I had Parker at my house. She probably did. Your mom says so. Okay. No, like after, like she, yeah. Whenever I had her. Let's solve an exponential equation. Sure.
Just wait till we get to logs.
Oh, Friday's a big day.
What are you doing Friday?
Logs.
No, no one's gonna be here.
Who's not going to be here?
It's an
Raise your hand.
independent.
I'm going to Louisiana. I'm going with work. Work has actually made me like Louisiana, bro. No, you got to
Okay. Who is that on your shirt? That's you.
That boy right there.
Okay.
So, are you actually gonna do? You said yesterday you weren't, well, or Monday that you had one.
Did I?
Yeah, you said not doing.
Who's the most gullible?
I don't want to have to make up another thing.
Okay. Let's say.
I have things to do other than.
Oh.
What does x have to equal? 2. X would have to be 2 to make that equation true, right? Does that make sense to everybody? This is gonna, oh my gosh. This is gonna be the premise of what we're doing today. I know, I can't get it out. X would have to be 2. What if I switched it up a little bit and I said, okay, how about 7 to the x plus 1 equals 7 to the 5th power? Tell me what you're doing.
You're filling in the numbers of the x to make it equal the exponents of the second number. That
Can we just keep it like
If the bases match,
So if that's going to be the key, if the bases are the same, then the exponents must equal. Right? So the bases are the same. It's just one exponential piece equals one other exponential piece. If these are the same, then it follows that x plus 1 has to equal 5, and I can then solve that for x. Yes? What? We'll see. Now, it might be that, okay, we'll keep it simple. Just for one. Tell me here, what does n equal? Don't say it out loud. Mark that guy. Solve it for n. What does n have to equal? To make that equation true, solve it for n. What does n need to be? Are you being mean? Is he being mean? Why are you being mean to Lily Mae? She has not. Oh. She makes more money than you, so she has your alimony. Trina? Okay, yes, you set them equal to each other. I don't know. Let me see. Move the n. Thank you. Thank you, Sawyer. You see how even if you were being funny, it still made her smile. Oh my gosh.
hold on, there is a way to.
-7 minus 5 is -12. All right. Make it a little bit harder. Crank it up a notch, if you will.
Oh yeah, Johnny, you get lit.
You want me to always use x?
I don't like you what the
Kate actually did our
This is a problem. Because I've only talked about if it's something equals something, but there's more than one something over here, right? So yes, here's what you're going to do. We want to simplify each side first. So I'm going to have to think back to my exponent properties. That's right. If you are multiplying with the same base, you leave the base, don't combine both base and exponent. It doesn't become 9. It's still 3, but I add these exponents together. What is x plus 2? 2x plus 2. Now is it something you could solve? You don't combine both, just one. If I had x squared times x to the third, that would be x to the fifth. Or if I had 2 squared times 2 to the third, I don't make it 4 to the fifth, I still keep it 2 to the fifth. So same thing here. I keep the 3, but I add the exponent. Y'all with me? All right. Drop the bases now that it's just one thing equals one thing. Bases are the same. I can drop off and set these equal. I'm going to move the 2x first. But I'm also going to add the 1 without confusing by if I do 2 steps at once.
Yes.
Hmm.
My name is Jen.
Malaya.
How does nobody know this? I thought you were going with 10. I don't think it matters.
You're going to come with 2.
Please, ladies.
Mike Sawyer. He's going to 2 weeks. All right. Let's really kick it up. Are you ready?
This is what we've been striving to get to.
Stop.
You decide one day.
I don't know what it means. Like, I know it's bad.
You decide one day you don't.
What can I do?
You just make it's 1.
Yes, that's exactly what you have to do. Here's what you have to do, and this is where it gets hard, okay? I call this base manipulation. We have to make the bases be the same, but we can't change anything's value, okay? So this still has to be 6, and this still has to be 36 at the end of the day, but I could write it a different way, kind of like I could say that 10, I could rewrite that as 5 times 2. That's still 10, I just wrote it a different way, okay? So I can change, I want to change this one because I could make this one have a base of 6, right? So this, I could leave 6 to the 2x minus 10, but this one I would change to. Okay, so tell me what other way you want to change it.
Oh, you could do. Wait, you could do 2, and then change x to 6, right? X
Like
equals
that?
6. You can do that. No.
You could do that, but I would get this a little bit easier to go here. You won't always be able
change
to.
x to 6.
What? Well, yeah, you're solving, so now that they are the same, once the bases are the same, you can drop them off and set the exponents equal. Add 10. So you get 6x equals 12, which means x equals 2. X equals 6. Oh, 6, sorry. 2x equals 12, so x equals 6. Let's do another easy one, and then we'll do a hard one. Yeah. He just substitute. His last day is Friday. He's been going to school. He's just been doing this while he finishes his degree, and then no, an auditor,
Well, you gonna read books?
like an accounting.
Oh. Wait, what is he? Wait, I thought an auditor was like going once and twice.
All right, tell me what I can do. What can I force the base to be? 4, right? So this would stay. I'm going to change, yep, you just multiply. I'm going to change this to 4 squared, and then the y minus 3 is still there. So whenever I do this, this is distributing through to everything, okay? So be careful. So it's going to be y plus 2 equals 2y minus 6, exactly. So now you can go through and solve it, right? 2 equals y minus 6, so y equals 8. Yes, no, maybe so.
Maybe so.
I'm almost done, and I'll let you work on it. Why is it what? Almost. I moved the y, and then I added the 6. You messed up. No, you don't.
I don't hate math content.
Okay. One more easy one before we crank it up. I said that before, but I just want to make sure I tell you about this. You're exactly right, Josh. Negative exponent. This, I could change 1 over 7 is the same thing as 7 to the negative 1, right? Agreed?
I guess so. 7 to the negative 1, and then
The negative exponent will flip it. So really this is 7 to the 4x plus 11 equals 7 to the negative 1. And now they have the same base. So now 4x plus 11 equals negative. Subtract 11, yeah. You could, but then you have an extra step. I got negative 3. Let's see if you got it.
give us a sign that you're dead.
Don't blurt it out if you see it.
Everyone like this.
Yeah, blurt it out.
Nope.
Is it?
Oh, hey, Greg.
Once you actually get told,
Might be. Thank you.
Hey, where were you? You were in detention for 2 hours.
Tell me this without solving it. What is the base you used? That's right. 3. Why can't you use 27?
I have no idea.
How can you use 3?
We're rooted by a fraction.
Remember, you're looking for powers. 3 to the what is 27?
1/3.
3 to the
third.
The 2x is still there. Remember, I'm just writing 27 a new way.
Oh.
Wait, why are we rewriting?
Because I need the bases to be the same. You think 3 to the 12th is 243?
No. It's definitely 3 to the 5th.
3 to the 9th. 4.
I think it's 4th.
I think it's 4th or 5th, yeah. 4th.
It's not the 4th?
27 times, yeah, it's to
What's
the
the
5th.
5th?
It's
Okay,
to the
you're
5th.
right.
I'm getting trusted paper out.
3 to the 5th would be 243, yes?
Yep.
Now we can do 6x.
Minus 5x. And that will give you x equals -10, and that is the answer. You're welcome.
Final answer. You like it?
It's like 2 steps. Isn't it like 2 steps?
Just see a hole in your mouth.
Say that again.
I wasn't trying to make you laugh. I was just telling the truth.
You're dropping those threes whenever you solve it. Yeah. So drop them completely, and so it's just this equals this. Once they're the same, drop them.
Hey. Maybe you're wrong. I mean, definitely, but like, I think he's wrong. I know that.
No! I know the base.
What's the base?
The base is.
Hold up, what?
Wait.
4. 4 is the base, right? All right, so this one already has a base of 4. I'm good to go on that. How can I write 1 over 16 as a base of 4? 4 negative 2, right? 4 negative 2 would give me 1 over 16. The negative flips it, and 4 to the second is 16. This one's already a base of 4. Am I ready to drop the bases yet?
Yes. No.
No, because to drop the bases, right. So what do I do over here? Oh,
Well, no, you have to
no.
make the exponent.
Add them together. Thank you. If you, right, if you multiply with the same base, you add the exponent. So this is 2x minus 2. They don't have to. They just have to have the same base.
James,
Why
you
are your
want
eyes
a
so
juice?
red?
Here you go.
They only multiply whenever you raise a power to a power. All right, set them equal.
No, do minus 18.
Do minus 18.
Now you want to do divided by 2. Subtract 2 out next. Yes.
2x is what he meant.
And the answer is -5.
Give me one from your homework you think you might struggle with.
Number 8.
No, 2.
The whole set.
16. Let's look at 16. What? I don't have anything on Google Slides right now, so why would you need that open? Okay. 16. 1 over 9 to the A. Sorry, it's not an X, y'all. They do.
Your 5 is like, no, your 5 is like X.
You think?
No, you were thinking about it. When you're doing it, right? 5, 5, 5, 5, 5, 5, 5. See?
Okay. All right, what's the base? 3. I need it to be 3, right? I need them all to be the same, so what's the connection here between 1/9, 1/3, and 3? I can do a 3 as a base. So what 3 to the what power is 1/9? -2. The exponent that was there is still there. Remember, I just wrote this a different way. It didn't change values. I just wrote it a different way. How about 1/3? -1. Again, the A is still there. And this one stays the same. All right, so I've got 3 to the -2a times 3 to the -a equals 3 to the 16 minus a. Whatever shall I do? Okay, wait.
Dang it. I already got messed up. I wrote the A as a 9. That's fine.
So 3, that's right. 3 to the -3a. Oh, too much. Now I can drop the bases since they're the same. So -3a equals.
A equals -8.
Everybody, give me a thumbs on how you feel about this.
Based off that
Okay.
I just feel like calculator. College, what I think it is. Why not? And then do math under it.